Hey everyone, thanks for checking out my video today on the domain of functions. To start today, we got a couple questions we're going to talk about in class. Number one says, what two operations are illegal in the real number system? And I think we all know we can't divide it by zero, but another really important one that we'll use today is you cannot take the square root of a negative number. Second question, what do you need to use when solving quadratic and rational inequalities? We need to use a number line to visualize when the, let's see, supposed to be radicand, autocorrect, change it to radand, when the radicand, that's what's under the radical, will be greater than or equal to 0. And finally, what variable do we look at to determine the domain of a function? That is simply x. So let's take a look at a couple problems. First one, what is the domain of this function? This is just 5 points. Okay, so our domain is just going to be the 5 x values we see there in numeric order. -3, -1, 0, 2, and 4. Letter B. This is just a quadratic. A quadratic would give us a parabola. There is nothing that we can't use in quadratics, ever. So a quadratic will always have a domain of all real numbers. Okay, sometimes we write that like this, a double R, meaning all real numbers. However, when using interval notation, we want to use negative infinity to infinity. Part C. This one, we can't use every possible number for B. When the denominator is 0, that would make this an illegal graph. It would be what's called a vertical asymptote. So what we're going to do is we're going to set the denominator equal to 0, and that's a pretty easy equation to solve. It would be when -5 is B. So everything but -5 would work. Okay, so we can say x is not equal to -5, or we can say in interval notation, everything before -5 and everything after -5, I should say, or everything after -5. So negative infinity to -5 union -5 to infinity is our domain here. Part D. All right, now we have a radical, so we can't have what's under the radical be negative. So we want to set what's under the radical to be greater than or equal to 0. And if we solve this by adding 3x to the right, and then dividing by 3, we get x is less than or equal to 4/3. So in interval notation, that would be negative infinity to 4/3. And because 4/3 does make it 0, that's okay. We're going to put a bracket on there. So we're going to include 4/3. Letter E. So again, we want what's under the radical to be greater than or equal to 0. So solve this. We're going to say y plus 3, y minus 3, greater than 0. So equal to 0 is pretty easy to see. It's going to be when y is -3 or +3. And those are the two numbers we're going to put in our number line here. -3 and +3. Because it says equal to, we're going to put closed circles on those. Now, what about the 3 intervals between there? What we want to make sure is if we took an x value there, in this case a y value there, what we would get back is a positive value. So what you're going to do is you're going to take a test point in each of these intervals one at a time and see what we get back. For example, let's say over here, we picked -5. If you pick -5 and put that into here, would you get back a positive or a negative number? Well, it'd be 25 minus 9, which is positive, and that's good. We can take the roots of positive. So that interval is okay. Maybe in this interval, we'll take 0. That's an easy one to pick. If you put 0 into here, we're going to get a negative number, and that's not good. So we can't use that interval. And over here, maybe we'll pick 5. If we put 5 into here, we'll get back a positive number, so that's good. Again, you can pick any test number you want in those intervals. You should get back those 3 symbols. So the reason why we're doing this again is because we want to make sure what's under the radical is positive. So our final domain now is going to be negative infinity to -3, with a bracket, union, 3 to infinity. So we don't want this, where it's negative. Part F, we have a rational under the radical sign this time. So we gotta find out when the numerator and the denominator would be 0. That would be when x is 2 and x is -5. And those are the two numbers that are going to go on our number line. Because 2 comes from the numerator, this would make this 0, and that's okay. It could be 0. So it's going to get a closed circle. Because -5 comes from the denominator, that would make this undefined, and that's not okay. So -5 gets a closed circle. All right, now for the 3 intervals in between. Again, just pick random test points. Maybe over here you pick -6 and put that back into here and see what we get back. It would be -8 over -1, which would be a positive. Here, let's pick 0. Always pick 0 when you can. You get -2/5, which is negative. And here we can pick 3, and we get back 1 over 8, which is positive. So your domain is going to be this and this. In interval notation, that would be -infinity to -5, union, bracket, 2 to infinity. All right, next problem is a little bit of a review. So our domain is all the x values we can use here, right? So the lowest x value is -3, the highest is 1, but we don't include -3, we do include 1. So our domain is -3 to 1 with a bracket on 1. The range, the lowest and highest y values. The lowest y value is -2, the highest is 0, and it does hit 0 here. Not here, but it does here. So our range is going to be -4. Did I say -2 before? Sorry. I meant -4 to 0. And it does hit both of those, so those both get brackets. Increasing. Where is this function increasing? Where is it going up? That's going to be this interval right there. We only look at the x values. So our x values would be -2 to 0. So increasing interval is -2 to 0. Decreasing, it decreases twice. Here, -3 to -2, and here 0 to 1. So we say -3 to -2, union 0 to 1. Constant would be if this was a horizontal graph anywhere, which it is not. So there are none of those intervals. Zeros is where it crosses the x-axis. It might look like there's 2, but this one doesn't actually exist. Never actually hits it. So the only 0 is right there, and that's 0, 0. The y-intercept, when it crosses the y-axis, is also 0, 0. F of -2. All right, if we put -2 in, what we get back looks like -4. When is f of x equal to -4? So when does this function equal -4? Well, that actually happens twice. X equals -2 and x equals 1. So x equals -2 and x equals 1. Okay, on the next 2 slides, there are 8 practice problems that you should pause this video, try the 8, and come back and check out the answers when you're ready, or you can check them out on the key posted to Schoology. All right, I'll pause it. You can pause this video right now, and I'll scroll down to the next 4 answers in a few minutes. Here are the answers through 1 through 4. You can pause the video here if you need to look at it longer. And here are the answers for 5 through 8. Again, you could pause this video longer if you need to stay and look at the answers or work. Otherwise, thank you very much for checking out our video on domain, and we hope to see you again soon.